Okay, so this is going to be number 12 from page 356. And what we're being asked to do here is just evaluate. So like basically find what the exponent would be if this thing were written in exponential form. So something like this, right? They're all equal to x. That's what we're trying to find. The way we're going to do this, you could do this with the switching into the exponential and solving, but I'm going to leave it in the logarithm form. And what our job is, as we learned in class, was to try and make the base of the logarithm, so log base b, match the base of the argument to some exponent, let's say n, okay? And once we can make the base of the logarithm match the base of the exponent, they can kind of drop out and you're left with just the exponent, okay? So that's what we're going to do here. So for a, I'm going to have log base 2 to the 32 cubed. So our job here is to get a 2 in the place of the 32. Okay, so log base 2, 32 is going to be 2 to the 5. 2 to the 5, 2 to the 5, and then you've got to multiply by 3, right? Because if you put the 2 to the 5 up top, you're going to end up with the 5 and the 3 both being in the exponent, right? And then you'll notice now bases of the logarithm and the base of the exponential match. And so they're just going to drop out because they're inverses of one another. And you're just left with 5 times 3 is going to equal x. Okay, and so 15 is going to equal x. All right, so that's the name of the game. We're just trying to make the bases match so that I can evaluate the logarithms. Okay, so for b, log, now again, they didn't list what the base was here, so we're going to, it's 10. 1,000 to the negative 2 is equal to x. So our job is to write 1,000 with a base of 2. So I get log base 10. 10 squared times negative 2 is equal to x. Log base 10 and the exponential with a base of 10 drop out. You're left with 2 times negative 2 is equal to x, and so x is going to equal negative 4. Okay. Oh, I'm sorry. Made one little mistake there. You guys probably would have caught that pretty quick. Silly mistake. The 10 squared is not 100. 10 cubed is 100. Or 1,000, sorry. So 10 cubed, so this is going to be 3 times. It's a good thing I caught that. So negative 6. Sorry. Okay. So again, just 10 cubed is 1,000. Wasn't trying to build 100, I was trying to make 1,000. Question C. Log base 10, 0.001 to the negative 1. Okay. So I need to turn 0.001 into a base of 10. This sounds like some of your scientific notation work, right? So what we're going to do is say log base 10, 10 to the negative 3 times negative 1. This is going to equal x, right? Okay, and so 10 drops out. You're left with negative 3 times negative 1 is equal to x, and so x is equal to 3. Okay, one final one. Log base 1/4. The 1/16th argument to the power of 4 is equal to x. Okay, and so what I could do, again, I'm trying to make, this one's a little bit trickier, but same work. I'm trying to make 1/4 be the matching base there. So my question is, how do I write 1/16th with a base, like 1/16th is 1/4 to what exponent, basically, right? And so I could say, well, log 1/4 is going to be 1/4 squared to the power multiplied against 4 in the exponent kind of thing. Okay. So the bases now match. they drop out. You get 2 times 4 is equal to x. And so x is going to equal 8. Okay, and that's it. When we're evaluating logarithms, so you're ones that you can do without a calculator kind of thing, right? And the name of the game is just to make the bases match, both in the logarithm and the argument kind of thing. Okay.